Hello everyone. Today we will study new lecture, which is number 9. So we'll study two lessons or the last two lessons in Heart of Algebra, topic 1. Let us start. Graphing linear systems. If two linear lines intersect in the xy plane, then their point of intersection represents the solution to the system of the equation graphed. When a linear inequality is graphed in xy plane, the set of all points that satisfy the inequality lie on one side of the line called half plane. A half plane means the solution set or the region which represents the solution. This means every point in this region satisfies the two inequalities. When a system of linear inequality is graphed in xy plane, the solution set is region over which the solution have planes of individual inequality overlap. System of two linear equation. If a system of two linear equations is graphed in xy plane, then there are three possible cases. We have these informations many times. Case number 1. As you see, intersecting the solution set is 1 point, as you see in the graph. Case 2, parallel lines, there is no solution, as you see in the case 2 graph. Coincide means one over the other, infinity solution, because each point, any point on one of them is considered as a solution. Example 140. 2 over 3x minus half y equals 7, kx minus 6y equals 4. In the system of linear equations above, if the system has no solutions, what is the value of k? When we remember parallel lines, no solution means parallel lines, means that they have the same slopes. Since the system has no solution, then they have the same slopes. Solve the equation for y first, each one for y. We will get y equal 4 over 3x minus 14 and y equal k over 6x minus 2 over 3. So equate the slope by each other. So 4 over 3 equals k over 6. Do cross multiplication, you will get k is 8. Graphing a linear inequality. When we have inequality, the difference between there is or equal to or no, like dashed line or solid line. In the graph, this y plus 2x equals 6. We draw like one straight line and do the dash if there is no sign like or equal to. Shade the region which represents the solution. If the sign less than only, so shade under the line area. If the sign greater than, shade above the line area. Or choose a checkpoint like 0, 0 or any other point to the left of the line or to the right, the point which satisfies the inequality, then the shade in its direction. A checkpoint 0 and 0 in the graph before. So if you put 0, 0, 0 plus 0 less than 6, it is right. So we'll shade to the in direction of the 0, 0 area. System of linear inequality. The solution set of system of two or more linear inequalities is the region over which the overlap shaded area. Consider the system y less than or equal to x plus 1 and y greater than negative half x plus 4. This is the graph of the first inequality, and this is the graph of the second inequality, but you will draw in one plane, one over the other. So look at area I is the represent the solution. Maybe by overlapping, or you can take a checkpoint from this shaded area and must satisfy the two inequalities. It says that this is 0.6, if you plug in y by 2 and x by 6, so read the answer 2 less than or equal to 7, it's true. Also, the same point with the second inequality. If you plug in y by 2 and x by 6, so you will get 2 greater than negative 2, so it's true. Since both inequalities are true for the one checkpoint 26,2, then this shaded area is true. Hence, the bounded region is contains at 602 represents the solution. Test yourself in lesson 11. Now we will start last lesson in Heart of Algebra. It's named Working with Functions. A function is a rule that tells how to pair each member of one set, say x value with exactly one member of a second set, say y value. The rule is typically expressed as either y equal type of equation, graph, table. A set of all possible x values input is the domain, and the resulting set of y values output is the range. Equation as functions. A function is usually named by a lowercase letter, such that as for f or g, h. This is the famous letters in the case of function. The equation y equal to x plus 3 describes a function since it gives a rule for pairing any given x value with one particular y value input, and the number of input represent number of x, multiply it by 2 and add 3. Then the result, name the result. When x equals 3, by plug in 3, you add 2 times 2 times 3 plus 3 equal 9. If this function is called f, then the ordered pair 3, 9 belongs to the function f. This fact can be abbreviated by writing f of 3 equal 9, which is read as f of 3 equals 9. Here are some examples for evaluating function. If f of x equals 9x over x cubed minus 1, then find f of negative 2. So plug in by negative 2 for each x. So 9 times negative 2 over negative 2 cubed minus 1, calculate. So will be 9 times negative 2 over negative 9. So cross out 9 with 9, and negative divided by negative is positive. So then our final answer is 2. If g of x equal 1/3 x plus 3, then find 6 times g of x minus 8. So replace g of x by the given rule. So I write 6 open bracket half x plus 3 minus 8 equals, and distribute 6. So 2x plus 18 minus 8. The final result is 2x plus 10. Second one, if h equal x squared minus x, then find the value of or expression f of n minus 1. So replace hx by n minus 1. So n minus 1 all squared minus n minus 1. So expand the bracket, squaring bracket. It will be n squared minus 2n plus 1. Then distribute the negative to the parentheses, so negative n plus 1. Combine the like terms, so the answer will be n squared minus 3n plus 2. Example 141. F of x equals 2x minus k over 5, and f of 7 equals 3. What is the value of k? Solution. Plug in x by 7 and equate the answer by 3. So 2 times 7 minus k over 5 equals 3. Do cross multiplication. So 14 minus k equals 15. Then k equals negative 1. Example 142. F of x equals 3x minus 5. If 3f of n equals 30, what is the value of f of 3n? Solution. By the same way, plug in n multiply 3 times the function, but replace x by n. So 3 times 3 n minus 5 equated by 30. So this like equation has one unknown. So distribute 3 or divide by 3 both sides. So 3n minus 5 equal 10, and complete the solution. It will be 3n equal 15. Look at the required. Find f of 3n. So plug in by 15 in the original function. 3 times 15 minus 5. It will be 40. Example 143. If f of x equal 1.5x plus p and f of 6 equal 1, what is the value of f of p? First of all, try to put x by 6 and equate by 1 to get the value of p. 1.5 times 6 plus p equal 1, so p equals negative 8. because 1.5 times 6 is 9, and move it to the other side by negative sign, so 1 minus 9 is negative 8. Now get f of negative 8. F of negative 8 in the original 1, and put also b by negative 8, so 1.5 times negative 8 minus 8, calculated, it will be negative 20. So answer A. Example 144. If x equals 3x minus 1 and g of x equal 4 times f of x plus 3, what is the value of g of 2? First of all, get g of f, which is 4, replace f of x by its rule, so 3x minus 1 minus 1, so distribute 4x minus 4 minus 1 is negative 5, then g of 2 equals plug in by 2, 12 times 2 is 24, minus 5, which is 19. Example 145. F of x equal x squared minus 2x, what is the value of f of 2x plus 1? So replace each x by 2x plus 1, and expand the bracket, and distribute negative 2, and combine the like terms, you will get 4x squared minus 1, which is C. Determining the domain and the range of function. The domain of the function f of x is the largest possible set of real numbers x for which f of x is a real number. There are two cases when finding the domain of a function. I mean in SAT exam. Fractional function. There are two types of asking about their domain. Fractional function and square root function. For any fractional function, the rule will be all real numbers except zeros of denominator. This means you will equate the denominator by 0. In the case of f of x equal to x minus 1 over 3x minus 6, get the zeros of 3x minus 6. This means solve 3x minus 6 equals 0, so x equal 2. The domain is all real numbers except 2. Because if you plug in by 2, you will get number over 0, and you know any number divided by 0 undefined or has no meaningless or error. This can be written as x not equal to 2. Either you say all real numbers except 2, or you can write like x not equal to 2. Another example, for f of x equal 3x plus 5 for x squared plus x. Also solve x squared plus x equal, which is the denominator, equals 0, and you take common factor like normal equation, and you will get two solutions, 0 and negative 1. The domain all real numbers except negative 1 and 0, or you can write x not equal to negative 1 or 0. The second type of function, square root function, the domain is the set of all real numbers which makes the expression under the root sign will be positive or 0. So start by putting the expression under the square root sign greater than or equal to 0. So 3x plus 3 greater than or equal to solve for this equation. So x greater than or equal to negative 1. This is the domain. Another example, in the case of the root or square root in the denominator, must write 3x plus 3 greater than 0, not greater than or equal to, because the root in the denominator. And we mentioned before that no zeros in the denominator. So 3x plus 3 equal greater than 0, so the same answer, but x greater than negative 1, not greater than or equal to. Take care. The range of function f of x is the set of all values of y can have as x takes on each of its possible values. For example, in the case of f of x square root of 3x plus 3, then the smallest possible value when x equal negative 1, because the domain x greater than or equal to negative 1, so the smallest value of x is negative 1. So I'll try to plug in by negative 1 in the original equation, so I'll get it 0, so the range will be y greater than or equal to 0. Composite function notation. The output one function can be used as the input of the second function. The notation f of g of 3 means that the output of g of 3 will be input of the function f of x. So f of x equals 3x minus 1 and g of x equals x squared minus 2. So to solve f of g of 3, first get f of g of 3. G of 3 plug in by 3 in g, so it will be 7. And after you got 7, plug in f. So f of g of 3, which out of both of g of 3 was 7. So you can write g of 3 as 7. So now you can get f of 7, which is 21 minus 1 equal 20. In the positive way, sorry, in the opposite way, g of f of 3, first get f of 3 in this case, which is 8, then get g of 8, which is 62. This means f of g of x not equal to g of f of x. Example 146. Sometimes gives the functions like tables, as you see. There is first table to the left is f represent f of x, and the second table to the right represents g of x. Some value of the function f and g are given by the tables above. What is the value of f of g of 3? So as we said, we must get a g of 3 first from the table to the right. So look at in the table, when x equals 3, y value will be 1. And after we got 1, now this input in the f of x. So look at the first table to the left. So look at 1 will be 4. So the answer is D. Representing a sequence of numbers. An ordered sequence number can be represented using function notation. For example, if the first term of the sequence is 4, then f of 1 equals 4. The nth term of this sequence is given by the function f of n equal f of n minus 1, which is the previous term, plus n. Then successive terms of sequence after the first term can be obtained by replacing n by 2, 3, 4, because you have the first term which it's order 1, so f of 1 equals 4, so you can get from the second term. So by plugging each time in the function, and you have the previous term. So if I want to get f of 2, this means f of 2 minus 1 is f of 1. Already we have f of 1 like 4, so add 2, the same value of n. So 4 plus 2 equals 6. Again, if we want to get f of 3, you will write f of 2, the previous term, plus n itself, plus 3. So 6, already we got f of 2 was 6, so 6 plus 3 equal 9. This is the third term. The fourth term, f of 3 plus 4, by the same way. So 9 plus 4 equals 13, and so on. In this case, we can get term after the other. We can make jump, like find 10 f of 10 directly. No, step by step. You have f of 1, then get f of 2, f of 3, f of 4 in order. You can make jump in this case. A function may be defined explicitly or recursively. A function defined in the usual way as y or f of something type of equation is defined explicitly. A function such that f of n plus 1 plus n, where f of 1 equals 4, is defined recursive since each of its term after the first term is calculated using the value that come before it. Graph as a function. Since graph is a set of ordered pairs located on the coordinate grid, a function may be taken from the graph also. If function g of x shows the complete graph of the function g, as you see, then you can tell the following from the graph. The domain, as you see, the graph starts from left from -6 and end to 5. So the domain will be x greater than or equal to -6 and less than or equal to 5. Since the greatest set of x values over which the graph extends horizontally is from x equal -6 and x equal 5 inclusive, this means this is the domain. The range of g of x from down to up, we start by what? By when y equals 0 and the highest number of the y is 8. This is called the range. The greatest value of over which the graph extends vertically from 0 to 8, so inclusive. So the solution set or the solution contains a0 and 8 itself, inclusive. Domain and range of function. The line y equal 2 intersects the graph of a point for the g of x equal 2, which is -5 or 1. If you draw a line horizontally at 2, so there are two solutions, -5, 3 solutions, and at 1 and at 5 and at 4. We can answer many questions from the graph. If we ask about g of negative 2, look at negative 2 from x, read the y value, it will be 8. At g of x equal 8, then what is the value of x? So at negative 8 is x equal negative 2. What is x-intercept? The graph cut x-intercept at two positions, negative 6, 0 and 2, 0. We are called also zeros of the function. Example 147. In the figure, g of x, which could be the values of s when g of x s equals 0, this means the x-intercept. When you put y by 0, you want to get x-intercept. So we got it before, like negative 6 and 2 only. So the answer will be D, I and double I only. Example 148. The zeros of function f of x equal 25 minus x plus 2 all power 2 are what of these two numbers? Zeros means equate the equation by 0, so solve by intelligent method. X plus 2 squared equal 25, take square root for both sides, so maybe x equal plus 2 equal 5 or negative 5. So when you solve the first case, so you will get x equal 3, and when you solve the other case, you will get negative 7. So the answer will be D. Number 149. This graph is given. The graph above shows the function y equal f of x over the interval x greater than or equal to 0, less than or equal to 7. What is the value of f of 6? So get f of 6 first from the graph, you will get 2, as you see. So from the graph, f of 6 equal 2. Then look at 2 and read the answer. So f of 2 equal negative 2, then the answer will be A. Now we have finished topic 1 in SAT lessons or exam. So we have finished this topic. I hope you understand everything. You have now everything about topic 1, heart of algebra. Thank you so much. Try to solve everything I put in the video. Thank you. See you next time. Dr. Mostafa El-Ghazali.